Here's example 4 with reference triangles. So we're given tangent of theta is -1/2 and cosecant of theta is less than 0. Okay, so we don't know what cosecant of theta is, we just know it's negative. Okay, but then we're asked to evaluate basically these other 5 trig functions of theta. So evaluate cosine, sine, secant, cosecant, and cotangent. Given that tangent is -1/2 and cosecant of theta is less than 0. Okay. So just like with examples 2 and 3, so remember example 1 was a little bit different because we were given the point. But examples 2 and 3, what we did was we say, okay, what quadrant is theta in? Well, this one we have to do just a tiny bit more work. So what are we given? We're given tangent of theta is -1/2. What does that mean? That means tangent of theta is negative, right? So where is tangent of theta less than 0? What quadrants? Tangent of theta is less than 0 in quadrant 2 and quadrant 4. Okay. So we talked a lot about that in an earlier video. And a few earlier videos, I think, where each trig function is positive and negative, which quadrants. And we're also told that cosecant of theta is negative. So where is cosecant of theta negative? Okay. So cosecant of theta is negative in quadrant 3 and quadrant 4, right? So basically, what this says is, okay, tangent of theta is negative, so we're in quadrant 2 or quadrant 4. Cosecant of theta is negative, so we're in quadrant 3 or quadrant 4. Well, both of these guys are true together, so quadrant 2, quadrant 4, quadrant 3, quadrant 4, here's the common quadrant. So we have to be in quadrant 4 because both of these guys have to be true at the same time, and that only happens in quadrant 4. Okay? So basically what we just found out was that theta is in quadrant 4. So let's erase this so we can make our picture. But before we make the picture, actually, let's write this down here. Okay, so we just found out that theta is in quadrant 4. Okay. So if theta is in quadrant 4, now let's come off to the side up here and write which trig functions are positive, which ones are negative. Okay, just so that later on it's going to be easier on ourselves. Okay, we're going to make this easier on ourselves. So since we're in quadrant 4, cosine of theta is positive. Sine of theta is negative. Okay. What about the tangent? Well, that's the tangent we were given, so let's not even bother writing that down. We were given the tangent, so whatever. What's next? The secant. Secant of theta is positive, because remember, cosine and secant, they're positive together or they're negative together. Okay. What about the cosecant? We were actually given that's negative. Okay, cosecant of theta is negative, but also since the sine of theta is negative, cosecant has to be negative, because sine and cosecant are positive together or negative together. But more importantly, we were just straight up given cosecant is negative. And then lastly, how about cotangent? Well, since we are in quadrant 4, the cotangent of theta is negative. Or you could also say, well, hey, tangent of theta is -1/2, which means tangent of theta is negative. Since tangent is negative, cotangent must also be negative. Anyway, so we have it here. In quadrant 4, only cosine and secant are positive. Okay. Okay. Now that we have that established, so remember we didn't really have to do that, but it's kind of a good idea because it just makes it easier later on, so we don't have to worry about it again. So we just have it neatly off to the side here. And now let's go ahead and draw our picture. So theta is in quadrant 4, so our picture is just going to focus on quadrant 4. Okay, so here's the x-axis, there's our y-axis. So remember quadrant 1, 2, 3, 4, so we're focusing on quadrant 4 here. So here's our angle theta. So remember theta in quadrant 4, that means the terminal side of theta. So theta comes all the way around like this. So here's our angle theta in quadrant 4 there. Now remember, we're dealing with reference triangles, so with reference triangles, always pick a point on this terminal side. I'll pick it over here so I have enough room to work with. I'm going to make it perpendicular with the x-axis. So remember, for reference angles, for reference triangles, always go to the x-axis. Never go to the y-axis. No matter what quadrant you're in, always go to the x-axis. Okay, so we've actually done one example in each of the quadrants so far. So now we're doing one in quadrant 4. Okay, so now let me fill in this side of the triangle also. Okay. Okay, so now we have this here. What's so great about that? Well, what's this angle right here? What's this angle right here? How does this angle that I just labeled here, how does that relate to theta? Just like in examples 2 and 3, that's the reference angle, right? That's the reference angle, so I'm going to call that alpha. Okay, so this here is our reference angle alpha for theta. And again, we don't have to call it alpha, we can call it whatever we want besides theta, because theta is already taken. But anyway, this here is our angle alpha, It's a reference angle for theta. So remember, we talked a lot about reference angles in an earlier video and did some examples with those. So anyway, how's that beneficial to us? Well, what's the tangent of alpha? Tangent of alpha is positive 1/2. Why do we know that? Well, we know that because tangent of theta is negative 1/2 and alpha is the reference angle for theta. Okay, so remember, that's how reference angles and their corresponding angles work, right? So first of all, we were given tangent of theta is negative 1/2. Okay, so that tells us since alpha is the reference angle for theta, then tangent of alpha must be positive 1/2, because that's how reference angles work. Remember, tangent of an angle and tangent of its reference angle, they're exactly the same thing, except tangent of the angle might be negative depending on what quadrant the angle is in. And since theta is in quadrant 4, tangent must be negative. And actually, we were given that the tangent is negative 1/2 anyway. But more generally, since theta is in quadrant 4, tangent has to be negative. Okay, but why is tangent of alpha positive? Because first of all, that's just how it works with reference angles, but also more specifically, reference angles are always acute, right? So remember, reference angles are always acute angles because they're always this part of the right triangle here, so it's always between 0 degrees and 90 degrees, or between 0 radians and pi over 2 radians. So reference angles are always acute. Trig functions of acute angles are always positive. Okay, so trig functions of reference angles are always positive because reference angles are acute. Okay, so that's why tangent of alpha is 1/2, because it's the reference angle for theta, and tangent of theta is negative 1/2. Okay. Okay, so that's why tangent of alpha is 1/2. Now, how does that help us with this triangle? Well, let's come over here and write this down. So tangent of alpha is 1/2. What is the tangent? Tangent is opposite over adjacent. So when I say what is the tangent, what I mean is what is the tangent in terms of right triangles? It's the opposite side over the adjacent side. So if I want to label this triangle, now let me say, okay, let's call the opposite side 1 and the adjacent side 2. So here's alpha, so the opposite side is this. I'm going to call it 1, or its length is 1. And how about the adjacent side? That's up here, its length is 2. Okay, okay, that's great. Why is that great? Because now we can use the Pythagorean theorem to get this hypotenuse, and then once we have the hypotenuse, we'll have all three sides, so then we can use those to get trig functions of alpha, combine the trig functions of alpha with these facts up here we talked about earlier, and then use those to get these. Okay. Okay, so let's go ahead and start evaluating. So, well, first of all, cosine of theta, or no, sorry, before that I'm getting ahead of myself, sorry. So we have to get this hypotenuse here, r. So how do we get the hypotenuse? Pythagorean theorem. So remember, r squared equals 2 squared plus 1 squared. So r squared equals 2 squared is 4, 1 squared is 1, 4 plus 1 is 5. Square root of both sides, r equals, again, when you take a square root of something squared, there's a positive and a negative root, but let's just take the positive root because we're talking about the length of a side of a triangle. So we're just going to say r equals root 5. Okay, so let's write it like this. So r equals the square root of 5. Okay, so that's what's going on there. All right, now that we have that, we can get all the trig functions of alpha. Okay, now we have all three sides of this triangle, so we can get all the trig functions of alpha. So in particular, now let's go over here. Cosine of theta is the same thing as the cosine of alpha, right? Because remember, that's how angles and reference angles work. It's the same thing as cosine of alpha, except we might have to slap on a minus sign here. Do we? No, we don't, because cosine of theta is positive. Okay, since cosine of theta is positive, because theta is in quadrant 4, cosine of theta is positive, so cosine of theta is just exactly equal to cosine of alpha, no negative sign in front. Okay. Well, what is cosine of alpha? It's adjacent over hypotenuse, 2 over root 5. Which is a perfectly acceptable answer if you were one of my students, but if you have to rationalize or if you really want to, multiply by root 5 over root 5, and you get 2 root 5 over 5, which I do not believe is more simplified than 2 over root 5. Okay? Anyway, how about the sine of theta? So the sine of theta, well, because of reference angles, that's the same thing as the sine of alpha, but we might have to slap on a minus sign here. Do we? Do we have to? Yes, we do, because sine of theta is negative. Okay, remember, sine of theta is negative because theta is in quadrant 4, and if you're in quadrant 4, the sine of theta is negative. So because of this, we have to slap on a minus sign here, okay, to guarantee that sine of theta becomes negative. So remember, that's just how reference angles work. Okay, so now this is negative what? What is the sine of alpha? Sine of alpha is opposite over hypotenuse, 1 over root 5. So negative, okay, negative signs, 1 over root 5. Which again is perfectly acceptable answer, but if you're one of my students, I mean, that's perfectly acceptable. But if you have to rationalize or if you insist on doing it, multiply by root 5 over root 5, and the answer is negative root 5 over 5. Okay. Okay, so, but again, negative 1 over root 5, to me that's a little more simplified, but if you want to rationalize the denominator, then you'll end up with this. Okay? Okay, so that's the answer for sine of theta. Now for secant of theta, what do we got going on for secant? Well, actually, we don't need to look at the triangle anymore, right? So that's great. And we also don't really have to worry about these sines, SIGN sines. So now secant is the reciprocal of the cosine. What is the cosine? Well, it's 2 root 5 over 5, but I don't like that. I don't want to use that. So cosine of, secant of theta, let's write it like this. Secant of theta is 1 over cosine of theta, okay? And cosine of theta is, we just found out that's 2 over root 5, okay? So forget about the rationalizing stuff. Cosine of theta is 2 over root 5, so the reciprocal is root 5 divided by 2, like that. Okay, root 5. So remember, the square root's only on the, excuse me, only on the 5, so be careful with that. So anyway, that's that for the secant. Or if you really wanted to use this one, you'd flip that, you'd have 5 over 2 root 5, okay, and then you would multiply by root 5 over root 5, and then you would end up with 5 root 5 over 2 times 5. 5s would cancel, and you'd have root 5 divided by 2. Same thing here. Okay, so when you rationalize the denominator like that, you're really just creating more work for yourself. But anyway, really 2 extra steps and more work, right? Rationalize this to get that, flip that, then rationalize again to get that, or you just get this right away, don't rationalize, flip it, and get this right away, don't rationalize. Okay. Anyway, cosecant of theta, what's the cosecant of theta? Cosecant of theta is the reciprocal of the sine. Okay, so cosecant of theta is 1 over sine of theta. What's the sine of theta? It's negative 1 over root 5. Okay, we found that out earlier, negative 1 over root 5. So what's the reciprocal? It's going to be negative root 5 divided by 1. Or in other words, just negative root 5. Okay, so that's the cosecant of theta. How about the cotangent? Cotangent is really the easiest of all. Cotangent, we were given the tangent. Tangent of theta is negative 1/2. Cotangent of theta is the reciprocal. The reciprocal of negative 1/2 is just negative 2. Okay? So this is negative 2. Negative 2 over 1, which simplifies to negative 2. So anyway, that's the cotangent of theta. This is example 4 with reference triangles, and here we had one in the 4th quadrant. So not terribly different from quadrant 2 and quadrant 3, right? Just got to be careful about what's positive, what's negative, things like that. So anyway, that's example 4 with reference triangles. Here's the problem statement. Here are our answers again, and that's example 4.